Good day, students and viewers. You are welcome. In this video, we are going to look at Math 105, and the course title is Differential and Integral Calculus. Differential and Integral Calculus. So, and in this depth, we are going to define a function today. Function. So, definition. Okay. A function from a set A to another set, to a set B, is a rule that assign to each element of A unique element of B. So that is it. So you have an element from A, you assign a unique element of A to a unique element of B to an element of A. So we write F is a mapping from A to B. So we say F is a mapping from a set A to a set B. Or we simply write if A is an element of A, we'll say maps to B, element of B. So we say what? F is a mapping or a function. We're saying function. F is a function from A to B. That is this one. And for this, we say what? A maps, assigns to each element. So A maps to B. So we also refer to A as the domain. Domain of the function. And B as the codomain of the function. So that if F is a mapping from A, is a function from A to B, and X is in A, then we write f of x to mean the image of X in A. And this element is clearly an element of B. So f of X now is an element of B. And this is how it goes. If this is a set A and this is a set B, to elements of B. So here is X in A, and through F, you get f of x in B. So meaning F is a mapping taking x to f of x. Or a function. F is a function taking x to f of x. Do not bother. I am using the word mapping and function unanimously. So they mean the same thing algebraically. So do not get distracted. A mapping is simply the same thing as a function. So now a function from a relation point of view. So if you can recall, we have defined a relation R. Take R as a relation. We say it's a subset of the Cartesian product A cross B. And that is a relation from a set A to a set B. So we can take, let's take an example. So an example here, if you have your A is equal to 1, 2, 3, and B is equals to AB. So a relation now from A to B to be defined as the ordered pair, you know, it's a set of all ordered pairs. So it's a subset of the Cartesian product. So it's an ordered pair. So you have 1, comma A. You can have 2, comma B. You know, not all the relation, not all the ordered pairs, but just a subset of the Cartesian product. So a subset of all the ordered pairs is now a relation. So if you look at this, 1 is assigned 1 in A is assigned only one element in B by this relation. And so 2 is assigned only one element of B, namely the element B. So no element from A has 2 images in B. And therefore, in this relation is a function. So R now is a function. From A to the set B. So now what is a relation, or what is a function in terms of a relation? So a function, or we say a relation from A to B, no, A and B are sets, we know from a set A to a set B is a function if each first entry, of the ordered pairs appears only once. It is unique. So you see, 1 appeared only once, 2 appeared only once in this as first entry in this relation. So take example now. So now example, what is not a relation now? It's a relation that is not a function. So this is, I want to give an example of a relation that is not a function. So so we let A to be equals to ABC and B to be equals to XYZ. So let R and R to be equal to, so R is equal to X comma A and then XB, YB, and then ZC. Clearly, this is not a function. It's a relation, but not a function. Why? Because X is mapping two elements. See, if you write this, let me diagrammatically, if you write this as this is A, this is A, X, Y, and Z. This is from B to A, B, C. See, by this relation, X is mapped to A, X going to A, and X is mapping to B. See, Y is to B, and then Z is to C. See, why is it not a function? It is not a function because X is having two images in the codomain. See, X has two images, namely A and B in the codomain. So since f of X is equals to AB, we see then R is not a function. It's not a function from B to A. So R is not a function from B to A. Because for all elements of the domain, you have f of X to be a singleton. For all X in B, f of X must be a singleton set. That is the meaning of a function. So otherwise, it is not, because this is not a singleton set. And therefore, it's not a function, but it's a relation. Another example of a function, so this is example 2 and this is example 1. Another example is we consider the set X equal to 1, 2, 3, 4, and Y to be equal to the set containing let's say 8, 9, 16, even though, but so let Y be equals to this set. So if F is a mapping from X to Y defined by f of X is equals to X squared, then what is f of X? What is the image set? That is, you find all the f of X. No? What is f of X for all X in X? So f of x is equal to what? It's a set now for all x in x. So what is f of x? So we put capital letter X for the entire set now. So the square of 1, because that is defined by f of x is equals to x square. Okay, too. All right, for the entire set now, if you square x, the square of 1 is equal to 1. See, it is here in y. The square of 2 is 4. The square of 3 is 9. The square of 4 is 16. And that is f of x. So diagrammatically, we have x, 1, 2, 3, 4, and we have the set y. This is 1, 4, 8, 16, and 9. So the square of 1, this is via f. The square of 1 is 1. The square of 2 is 4. The square of 3 is 9. So the square of 4 is 16. You see, this is a function. Even though this element has no pre-image, then it's still a function. But all the elements here must have a corresponding image. Every element here must have one image in the codomain. So this is the domain, and this is the codomain. So the set of all f of x. So now the set, so we have x now, the set f of x is called the range. It's called the range of f. The entire set here is y, which is the codomain, but the set of all elements, that have pre-images in y is called the range. This element 8 has no pre-image, and so it is not in the range. Therefore, we know that, so we clearly say that the range of f is a proper subset. This is a proper subset of domain, of the codomain of f. It's properly contained. So it's a proper subset in this case. But if it is not in general is a subset, not proper. This proper works only in this case. But in general, the range of f is a subset of the codomain of f. So that, sometimes the mapping can map every element in the codomain can have a pre-image in the domain. And so if that happens, then you see that the entire codomain is equals to the range, or the range equals the codomain. We are coming to that later. We'll explain in detail in terms of the types of function. So let's talk about the types of functions. Let's talk about the one-to-one function. One-to-one function. For a function f taking a to b is 1, 1, meaning is one-to-one. Sometimes we just write one-to-one like this to mean one-to-one function. If for all x, y in the domain in A, because A is the domain now. So now f of x is equals to f of y, meaning implies x is equal to y. Two images, two elements will have the same image if and only if they are equal. So meaning each element will map to one point, meaning each element in the codomain receives only one pre-image. For example now, for example, the function f of x equals to f of x is equals to log x. Is one-to-one. It's one-to-one on the set of real numbers. It's one-to-one because the logarithm of a number is unique. The logarithm of each number is unique. And so the function of logarithm is a one-to-one function. The function we have defined in example 2, also the function f of x is equals to x squared on R is not one-to-one. It's not one-to-one since, you see, if you have f of mine is not one-to-one, you see f of minus 2 is equals to f of 2, and that is equals to what? 4. So it is not one-to-one because these are two distinct numbers having the same square, and so it is not one-to-one. Since f, you have minus 2, you have 2, and this is the range, this is the codomain, even though it's the same set, but you have 4 here. So 2 is mapping to 4, and minus 2 is mapping to 4. So the function is not one-to-one. So that is the one-to-one function. Now let's look at the onto function. So this is the second one, the onto function. A function from a set A to another set B, to a set B, is said to be onto remember we have defined codomain and the range. is said to be onto if the range, if the range of f equals the codomain of f. That is, f of x is equals to codomain of f. So let's denote the codomain of f as the codome of f. A simple example here we can consider. Let's have an example. This to serve as example number 4. So we let x to be equal to 1, 2, 3, and y to be equal to 1, 4, and 9. So we define f of x to be equals to x squared on this set. So now a function from x to y to be defined as f of x is equals to x squared. So we simply see that f of 1 is equal to 1 because the square of 1, f of 1 is equals to 1 square, and that is equal to 1. See, f of 2 is equal to 2 square. So I don't have to be putting the bracket, I can just leave it open, and that is equals to 4. F of 3, this is equals to 3 square, and that is equal to 9. So diagrammatically, you can write x here as 1, 2, 3, and y here to be 1, 4, and 9. You see 1 is mapping to 1 because the square of 1 is equal to 1. 2 will map to 4 because the square of 2 is 4. 3 will map to 9 because the square of 3 is 9. Within these two sets, and the definition of this function, we see that f is 1 to 1. F is onto. Clearly, because all the elements of the codomain are having, each is having a corresponding pre-image. All the elements of the codomain are being mapped to by at least one of the elements of the codomain, and that is the meaning of onto. So using the same function, but with different set now. Let's change the set y. So this you serve as example 5. The same definition of f of x is equal to x squared, and we have x to be equal to 1, 2. Let's change even, let's say minus 3 and 3. So y to be equals to 1, 4, and 9. So that you see f of x is equal to 1 square, and that is equals to 1. F of 1. So f of 2 will be equal to 2 square, and that is 2. That is 4. F of minus 3, this is equals to minus 3, square, and that is equal to 9. F of 3 is equals to 3 square, and that is also equal to 9. So we see that minus 3 and 3 are having the same pre-image, are having the same image in the codomain. So you have, this is X, and here is Y. So by F, so we have 1, 2, minus 3, and 3. And here is 1, 4, and 9. So 1 is mapping to 1, 2 is mapping to 4, minus 3 is mapping to 9, and 3 is mapping to 9. This function is onto the function here, f, taking x to y, is onto, but not one-to-one. So we see it is possible to have a function that is one-to-one and not onto. It is also possible to have a function that is both one-to-one and onto. It is also possible by this example to have a function that is onto but not one-to-one, such as this. So now, definition. So definition, bijective function. A function taking a function that is both one-to-one and onto, both one-to-one and onto, is called a bijective map. So a function is a bijection if it is both one-to-one and onto. So remember that if a function, remember that an onto function is also called a surjection or a surjective map. So that's just an additional terminology or a name for an onto function. Just like the one-to-one function, some authors do call it a faithful function or injection. One-to-one, faithful, injection, all these are names of the one-one functions. So now, example. Example number 6. Okay, let x to be equal to, say, 1, 2, 3, 4. These are the elements of x. And y to be equal to, set 0, 0, 1, 2, and 3. So define, so we define now f of x to be equals to x minus 1 as a function from x to y. So from here we see, let's see the range. F of 1 is equals to 1 minus 1, and that is equal to 0. F of 2 to be equals to 2 minus 1, and that gives 1. F of 3 to be equals to 3 minus 1, and that is equal to 2. F of 4 to be equals to 4 minus 1, and that gives 3. So that gives 3. So this is the range now. So you can write the range of f now. The range of f to be equal to 0, 1, 2, and 3. So you see that the range is equals to the codomain. And that means the function is onto. Clearly, every element of x is having an image here. No element of y is receiving two pre-images. And so clearly the function is one-to-one. So f is, okay, since every element of y is having one pre-image, we say that the mapping then f is one-to-one, because that is how we define one-to-one. And since the codomain of f is equals to the range of f, the function is onto. And so the function is one-to-one and onto. And so if a bijection is onto, and therefore a bijection. All right, this will be the end of our video for today. See you in the next video, and thank you for watching.